name is Nuraini Nadira binti Kamal Arifin, and my metric card is CE190049. So for this PBL1, I will present introduction, solution for Q2, and the conclusion. So first, for the introduction, in terms of technical definition, signal to noise ratio (SNR) is a measurement being used in science and engineering that compares the level of a desired signal to the level of background noise. Next is in analog and digital communications, SNR can be determined by using a fixed formula that used to compare the two levels and returns the ratio. With assuming that signal and noise are measured at the output of bandpass filter that typically used in echo sounders and are limited to the same bandwidth. Then if the noise is uncommon enough, which when SN is low, it can slow down a wide range of data transfers. In an industrial environment, has the ability to cause catastrophe with the control system process. Then there's will no system can continue functioning properly without proper communication. Last but not least, in wireless technology, the key for better device performance is the device ability in distinguishing the applied signals as reliable information from any background noise or signals on the spectrum. So for the next slide, I will pass to my other group members.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizul Shakir bin Muhammad Hamzani. My matrix number is CE190085. I will present about project background and objective. So for the project background, first, purpose of this PPL to reduce the noise impairment in the receiver. Second, the receiver signal strength to achieve the same performance without any effect of extra environment noise, defined as the received signal strength to achieve the same performance without any effect of additional environmental noise. Third, compress the level of a desired signal to the level of background and to determine the manual calculation by using a fixed formula. And last one, include simulation using MATLAB software to determine that either get the same answer as manual calculation. Next, objective. To measure the sensitivity performance of a receiver, to compare the signal and noise levels for a non-signal level, to study the difference between signal and the unwanted noise, and the last one is to improve and enhance the signal to noise ratio output discussed without taking into account the conditions and limitation. Next, I will pass to my group members. Shamil. Assalamualaikum. Thank you.
Hello, Assalamualaikum. My name is Syamil Bakri bin Ibrahim. My metric card is CE190170. So today I would like to explain about this PBL activity from ECS project. So my part is purpose of project and problem statement. So I'm going to explain to you what is the purpose of project that we are going to do. So firstly is to compare the level of a desired signal to the level of background noise. Second, to determine manual calculation by using a fixed formula that used to compare the two levels and returns the ratio. Third, to perceive the impact of performance from SNR network is SNR is signal noise ratio. Okay. So next is the problem statement. So problem statement from our project is active vibration control consists of two parts, is estimating the frequency of the disturbance and the given this frequency, designing a controller to reject the disturbance. So yeah, that's all from my part. Okay, so I'm going to pass to my group members. Thank you.
Hi, my name is Jongshin Lin. I will explain villa table for our group PBL. So for our group, we have 6 facts, ideas, learning issue, and resource needed or action plan. So for the first fact is the higher number means better specification. The idea for the facts is signal to noise value can impact a system overall sound quality. The learning issue for the fixed idea is how does the noise affect SNR? For the action plan for the learning issue, the first learning issue is we do the research online and analyze through calculation regarding SNR. The second fact is SNR depends on the original properties and the information and the effects suffered by it in the processing prior the estimation. The idea of the fact is sinusoidal signal as a consequence of SNR reduction due to noise aliasing when undersampling is applied. The learning issue for the idea and facts is how can the output be analyzed for various signals? The action plan that we did for the learning issue is we proceed a calculation that can obtain user value to design, signal, and analyze the output accordingly. For the third fact is can give better signal when SNR increase. The idea for the fact is if audio component list a SNR of 100 dB means that the audio signal level is 100 dB higher than the noise level. A signal SNR specification of 100 dB is considerably better than one that is 7 dB or less. The learning issue for the idea is a higher signal to noise ratio. Is it better? So for the action plan learning issue is we do the research main cause that can affect by SNR in wireless communication or network. For the fourth fact is noise performance and the sensitivity of a radio receiver can be measured. The idea of the fact is compare the signal and noise level for a non-signal level. For example, the signal to noise ratio. For the learning issue of the idea is there a current available method used to increase the system of SNR? For the action plan, we analyze research paper to find out how SNR affect the wireless communication on network. For the fifth fact is do an interactive calculation electronic communication system for education purpose. The idea is all students can understand SNR using the calculation. The learning issue for the idea is can share knowledge about SNR using calculation. Action plan is to create a manual calculation that is easier to understand. The last fact for this filler table is learn more about SNR. The issue is why is SNR important? So we are lack of experience and knowledge about SNR. So for the action plan, we do paper review on journal about SNR. So now I will explain the flowchart for our group PBL. So first of all, of course, we have to identify the problem and also our future process. What is our future process? So after that, we do a group meeting and define the project characteristic. Then we do the research regarding the SNR. While we doing the research regarding SNR, we can start the report writing and manual calculation. So the manual calculation, we have to do it based on the specification given in the question. After we success get the correct value, we can go to the next process, which is the project report writing. If we can't get the correct value, then we have to go back to do the research regarding SNR. We have to know how to do the calculation, and so on. So the last process area of our flowchart for our PBL group PBL is we finalize the final report, compile everything, and we do the video presentation. So that's all from my part. Thank you.
Greetings to Dr. Idri. I'm Honlik King, and now we will enter into the calculation. So to propose a solution to product the highest signal to noise ratio SNR output of the communication system. So we have this initial condition, which is the first one is the input signals SI is equals to 5 watt, and then we have the bandwidth, and then we have the gain of the each amplifier, and then we just convert the unit if necessary, and we have also the temperature of the antenna receive and also the chambers. So by using the initial condition, firstly we calculate the total noise temperature, which is TE equals to, since we have 3 amplifiers, so we start with T1 plus the T2 over the gain 1 plus the T3 over gain 1 gain 2. So at the end we got our total noise temperature is 526.08 Kelvin. After this we calculate the noise figure of each chamber. So the formula is F equals to 1 plus the TE, which is from the total noise temperature over its temperature. So we got F1, F2, and also F3. After this, we can calculate the total noise figure, which is the Ft equals to F1 plus F2 minus 1 over A1 plus F3 minus 1 over A1, A2. So we calculate it and then we convert it to the dB unit, which is 5.248 dB. By using the value of the received signal input and also the bandwidth, first we calculate the input noise, which is equal to KTB, when K is the Boltzmann constant and the T is the absolute temperature in Kelvin, and also the B is the bandwidth. So we got 1.7 times 10 power of negative 12 watt. By this value, we calculate the input signal to noise ratio, which is SI over NI. So by calculate it and then convert it into the dB value, so we got the signal to noise ratio input is 124.68 dB. Finally, we can calculate the signal to noise ratio output SNRO equals to the SNR input plus the NFT, which is this one. So total we got 129.928 dB. So that is all for the manual calculation. And now we will enter the simulation. And now we will showing a little bit of simulation by using MATLAB. So basically we just transfer the calculation part into the MATLAB code just to verify the answer. So firstly, we're going to insert the input of number of stage, the gain of all amplifiers, and also the temperature of each chambers. So by this input, we're going to have the total noise temperature and also the total noise figure. And after this, we also have the input of the antenna temperature, the bandwidth, and also the received signal. So by this input, so finally we got the signal to noise ratio output of the communication system in dB. So now we are going to run the program. So firstly, for number of stage, we have 3, so we enter 3 and enter gain of all amplifiers in Unilus in error format. So it's actually the square bracket, and the first gain of the first amplifier is 2.512 space, and then the second one is 3.162 space, and then the third one, which is 20. Enter. After this, we have to enter the temperature of first chamber in Kelvin, which is 350. The second one is 300K, and the third chambers in Kelvin is 450. So first we got the total of the noise temperature, and after this we enter the noise figure of first amplifier in Unilus, which is we can use the one we obtained from the manual calculation. So from the manual calculation, the noise figure of first amplifier in Unilus is 2.503, and the next one is the second amplifier is 2.754, and the third one is 2.169. So we got the total noise figure and also in dB. And after this, we enter the internal temperature in Kelvin, which is 308. Bandwidth is 400 mega, so it is 400 times 10 power of 6, and the received signal in watt is 5. And finally, we got the input noise, and also we got the signal to noise ratio input, and finally we got the signal to noise ratio output of the communication system in dB, which is equals to 129.933205, which is nearer to the manual calculation result, 129.928 dB. So we can conclude that it is the solution meet the desired criteria, which is the signal to noise level analysis of this cascaded amplifier system. So that is all for the calculation.
Solution for question 2. For question 2 is needed the ways to improve and enhance the signal to noise ratio output discussed without taking into account the conditions and limitations. The first way is reducing the noise factor. We may deduce that the noise factor F is inversely proportional to SNR out, implying that the lesser F, the larger SNR out. As a result, the larger the SNR out, it's better. So this is the formula we use. In addition, from the mathematical formula of output signal to noise ratio, SNR out is equal S out divided by N out. Then from Friis formula, the F1 will give the largest impact to our total noise factor. Thus, the smallest F1 is chosen to produce the smallest FT. So FT is equal F1 plus F2 minus 1 divided by A1 plus F3 minus 1 divided by A1, A2, and so on. The equivalent noise temperature, TE, is directly proportional to the noise factor F according to the formula. As a result, the smaller TE will result in a smaller F. TE is equivalent noise temperature. T is environmental noise, which is equal to 290 K. So the formula is TE equal T times F minus 1. Thus, the smallest initial temperature chamber is utilized to place the first amplifier with the maximum gain, resulting in the smallest F1 and the highest SNR out. As a result of the relationship, the gain of the amplifier can be increased to improve the output of the signal to noise ratio. To summarize, we require a lower ambient temperature and a higher total gain power in order to achieve improved SNR out. So that's all from me. Thank you. So in conclusion, from this PBL, we enable to identify the relationship between output SNR and input signal power. Then we can see that SNR permits the separation of random signals with the same probabilistic properties into signals that can be referred to as signal and noise. Plus, it is important to note that the noise radar values can be determined using the manual calculation. So that's all from us. Thank you.